Hey everybody, welcome back to the 125th episode of Taps and Patience. That feels like a special number, even though it's not really. It's an eighth of an inch. I'm AJ with Subtract Manufacturing and Audacity Micro, here with Harrison of Precision Ingenuity.
How we doing?
How you doing, Harrison?
I'm doing pretty good, all things considered. We're about to have Weston back this week, so for the first time in like a month and a half, we're both going to be there.
Woohoo! Finally a normal week.
So start catching up on a bunch of stuff. What about you?
So last week was a busy teaching week for me. Next week will also be a busy teaching week for me. I did do some machining stuff, though. I did ship a couple parts. They were fairly simple ones, but they shipped, by golly. And
yeah.
In the last episode, did we talk about the parts that I made for Subtract, where I used the Aroa system to fake having a 5-axis?
Yeah, we talked about that some.
Okay, we already talked about those. I couldn't remember if those made it into the last episode or not. I just recorded a video on how I did that, basically.
Okay.
The customer decided that I probably shouldn't show those parts on YouTube. And so I made like a different version of the part that was YouTube safe and made a video showing off that system because it worked so well. I'm not sure if that came across in the last episode, but it was just so fast and seamless.
Mm-hmm. Yeah, you mentioned that it was pretty awesome, and the problem was that you couldn't do a true one-piece flow because you only had one angled block, and so like to get both sides and then stand it up vertical or some whatever order of operations you were going, you couldn't one-piece flow it truly.
Yeah. The real problem was that I was like on day one, I didn't have the end mills to do the final operation. And so I did the first 3 ops on day 1 and then the last op on day 2. But
I had a little exciting time this week as well on some parts.
Uh-oh.
Yeah. So Weston accepted a Xometry job while I was gone, and I got the opportunity to do it.
I feel like choosing Xometry jobs for someone else to do is awful.
Honestly, the parts were really simple. It should have been a really easy job. But I broke a card. Weston only ordered me one piece of material for each part with no spares. And then I had a 1/8 inch, or a little bit bigger than an 1/8 inch, carbide drill break off in a slot. And I was pre-drilling the ends, and then I was gonna go back and forth. And one of my pre-drilled holes, it broke off, and it was my only piece of material, and it was very stressful. So,
did you get it out?
Yeah. So what I ended up doing in that case is I went ahead and machined the slot, and I found a method that actually it was a little bit more time intensive. But it was actually, it only added like an extra 2 or 3 minutes. And I did it without pre-drilling the holes. And anyways, during that process, I just opened up the slot. And thankfully, the slot went all the way through the part. And then when I flipped it over, I had a small section that was where that drill broke off. And so I just came in and just slowly ate it down until I saw the tip of the drill. And then I took a punch and punched it out from the other side. And then finished it up. So
that makes sense.
And that ended up working. But I tried everything from the top side first. And the thing that was annoying was when it broke with material. And this was stainless steel. It broke with stainless steel twisted around the drill, holding it in place. And so what ended up happening and the cause of this is that this happened to be the same drill bit that we use for an M4 or M3 tapped hole. I think it's M4 because it was just a little over an 1/8 inch. And I've been slowly speeding up the feeds and speeds for that drill just because it was going slow. But I was doing that on the default one. And every time I used that drill, I would do it from a template. And so it wasn't actually updating the template. And so when I ran that, it was running a feed and speed setting that I had never verified. And it was too much. So that's what caused it to break. So, and then I went back and I was like, oh, this is way too fast. But I made that adjustment like 6 months ago, and I just had never used it. So because every
That's
time
the
I
problem.
yeah
That's one of the problems with Fusion's tool library and how things don't backlink and
yeah
all that stuff.
yeah. So I thought it was a safe setting, and it was not.
Yeah.
So, but anyways,
Have you ever run your library through Toolpath's pre-tool?
no, I haven't. Well, maybe I have. I might have, but I don't know if I've saved it as the one that I'm using currently. I think I used it, but I don't think I saved it into Fusion. I just
Okay.
tried it out on a couple things.
Yeah. I basically at this point use that as a starting point all the time.
Mm-hmm.
And I generally just have to make it more aggressive. So it's
Yeah.
like I at least everything I've done so far, unless it's a weirdo tool like a long reach or whatever, like the I know that what pre-tool is going to spit out will be the most conservative that I'll run it at, and
Mm-hmm.
like I just know it'll work. I can trust that those speeds and feeds will work. They'll be super conservative, and they'll just work. And if I need to save time, then I start aggressing or bumping them up to be more aggressive.
Gotcha.
Uh,
Well, almost all of my tools have settings that are known good. There's very few,
yeah,
but when I get some new tools, I'll definitely make sure to try that out some. Can you do one or two tools, or does it do the whole library?
it does the whole library, but I think you could like I I don't think you can insert a library into a library, but you can upload a library, copy and paste the tools out of it, and then delete it. Delete the old one.
Does it delete the ones that are already there, or does it just add new ones?
The speeds and feeds, there's a checkbox, and you
Oh,
can
okay.
choose. You
Okay.
can choose delete or not delete.
Okay. Then I'll probably just do that with my default library and just keep my old feeds and speeds, because as long as I can keep my old ones, those are all proven out and good for the most part. Obviously, there's still exceptions every once in a while, but
Yeah.
but for the most part, they're pretty good, and I'm pretty happy with them.
I have finally moved over to being entirely on the subtract tool library system, and it's been so nice. The production job I was running was kind of my last little vestige of my old system, which was
Mm-hmm.
basically not a system. Um, but now that everything's a lot more standardized, I'm like entering the information for every tool into PathPilot because PathPilot lets you type in a full description of the
Mm-hmm.
tool. Um, and I've been using the same tools at school, like the same standard tool library at school when I program things. And it like just, oh man, having a system is so nice. It's amazing how much time and broken tools it prevents.
Now, are you using your Haas OM at all these days?
My office mill has been rather idle. There's been a couple times where I've spun it up for like a weird one off thing, but at this point, I probably should sell that machine.
Also, I was wondering is, do you need to fix it and get it going, or are you going to try to get rid of it?
Right now, it's basically a backup spindle for me. It's insurance.
Okay, fair enough. So, do you want to fix the spindle on it then? Okay,
I do.
let me ask you this: is the reason it's a backup machine right now because the Tormach is able to do everything, or you're gravitating to it because it's easier to use, or is it because the spindle on the other machine is problematic and you just don't want to mess with it?
I'm not sure at this point. You know, I have said a million times that I'm going to get that spindle rebuilt, but I haven't yet. And like money talks.
Mm-hmm.
And sometimes you just have to accept the thing that you think you want is either the thing you don't actually want or just the thing that doesn't make sense. And maybe at this point, it just doesn't make sense to get that rebuilt. I mean, yes, if that spindle was in good shape, I would probably use the machine a lot more. I mean, right now I'm using Haas controls far more than I'm using Tormont controls.
Mm-hmm.
Um,
So my question is, what's the differentiator between those two machines? Like, what in your world with the parts that you're using, what makes you gravitate towards the Tormach? Is it ease of use? Is it like what is it?
Honestly, a lot of it's probably ease of cleaning and mess. Where, these office mills, even when they were brand new, were messy machines.
Mm-hmm.
And mine is not brand new, and it is a very messy machine. The
Okay.
Tormach is just kind of like you spray it down with the hose and you're done. You don't have to do much. But with the office mill, the way the door is designed, it builds up coolant and chips on it, and just opening the door dumps chips and coolants all over your floor. And like honestly, that's probably a lot of it. It takes so much more cleaning.
Okay. Like I'm not trying to bash either machine or say one machine's better than the other. I just want to know like why you gravitate towards one machine, and if you've actually thought about it enough. Because like, go ahead.
These like pseudo 4-axis parts are probably a pretty good example because I could have done the first 3 ops on the Tormach and then the last op on the Haas, where the faster spindle would have actually mattered. Mm-hmm. And I didn't on those ones because I was worried the finish wouldn't be as good.
So
it would have cut my cycle down by half, probably.
So that is purely spindle.
That was purely spindle because I have my Aroa system on both at this point, and so like it would have just like I wouldn't have to do a new fixture or anything. It's just moving it over.
Because your reluctance to use that machine means one of two things: A, it's the spindle and you need to get it fixed, and then you will start using it more and keeping your stuff between the two, or B, you don't need it at all and it's taking up space and you need to get rid of it. I would say that your hesitation to use it is going to push you into one of those two more and more.
Yeah. I was thinking about just buying the bearings. My group of students right now at school are from a like industrial maintenance department, and they say they rebuild spindles all the time. And I was thinking about bringing it in and be like, hey, what are you guys doing during lunch?
So is it a money issue then for getting it rebuilt? That's the main reason?
Yeah, that's a lot of it is like, cash is always limited, and this has just never been a priority.
Yep. Fair enough.
So I have the Tormach. It makes great parts. It is faster and easier to use. Though I will say, I have not found a single machine that beats the ergonomics of that office mill. It is so nice for like actually working in the machine.
Just because of how much it opens up?
How much it opens up and how close the table gets to basically your waistline. I really like the ergonomics. It's just a very messy machine because the door design is awful.
Can that be fixed with anything like 3D prints or?
I've tried. I've never found anything for the door.
Fair enough. Well, what else you got going on?
I mean, other than the small number of parts I've made, I've been teaching a lot. I'm kind of in a period here where most of my time is dedicated to teaching, which I actually have some things to talk about there. And then Subtract has been running. We brought that new guy into Subtract to do social media, and he started posting stuff regularly, which has been great. There's probably still some system improvements to do there specifically in terms of quality of content. We're using some kind of AI tools that are good at cranking out content, but not all of it is super high quality and is probably just a waste of time. Or that's how I have told him to do things at this point. So it's like, it's, he's not doing a bad job. He's doing exactly what he's told.
Can you filter the AI content into like it has to meet a certain bar and then you can post it or something?
I mean, do you mean automatically?
No, I mean like if it can generate the content really quick, but then you can review that content and go, okay, this is good. We'll let this one go. This one's not. Or are you just posting everything without much oversight?
No, there is definitely a human in the loop there who's deciding.
Okay.
I think what we need to do is work on editing it a little bit more. And the AI generation tool that we're using has editing tools built in. But I think there's got to be some way to edit it a little bit more tightly. We had a couple shorts that have done pretty well, though. They've taken off. And
that's
maybe the meta in 2025 is you post a bunch of stuff and the algorithm,
Yeah.
hides everything that nobody wants, and then the stuff that is good will do well.
Yeah. Yeah.
So I
I
don't
don't
know
know.
that I don't know there yet.
Fair enough. Haven't had a whole lot happen for me. We did I did get a phone call from our new medical customer, and our CMM should be coming in shortly.
Awesome.
So our new medical customer called, and we did the first 10, and Weston talked to him after that, and this was the first time that I've actually talked to him after we did the first 10. And the lady I talked to was just super stoked with how the parts came in. Even though there was that one dimension that was a little out of spec, she said as a first run, it was the best they've ever seen. So they were real happy about that. And they changed the order from 200 to 1,000.
Oh,
So,
only a 5 times increase.
so they were like, she's like, yeah, they're really good, and we want to go ahead and change that from 200 to 1,000. I was like, oh,
Nice.
okay, we will get on that. So I'm going to get
What's the
a lot of exposure to hard milling.
what's the approximate cycle time on those parts?
We're doing them in 3 ops right now, 2 on the lathe, 1 on the mill. I don't remember what the lathe ops are. I want to say op 1 is around 8 minutes, and op 2 is like 3. And then on the mill side, I'm probably in the 6 to 8 minutes per cycle per cycle.
So not an hour.
No,
Like they're not that crazy cycle time wise.
no, but these will need to be inspected on and have reports generated and all that fun stuff. So we really need to get our CMM in. And I got the pre installation checklist, and one of the requirements on there was 108 inches for the roof for the ceiling clearance,
Oh.
and we only have 97.
Yeah.
And so I called the guy, and he's like, "Oh yeah, we have one that'll fit with that, but that's not how the order shows." And so Weston placed the order, but so I wasn't around when he did it, but I'm assuming that he put it all in because this has been a really big concern from the beginning, is that our roof isn't tall enough. And so the guy I talked to said he was going to go talk to the salesperson to make sure that he didn't put it in wrong and try to get that all switched. And I haven't heard back yet. So need to get that fixed and get the right paperwork, because it's not going to fit in 108. We need the shorter one.
Could you make that room taller if you needed to?
We could cut out a hole potentially and try to make it work, but I would really rather not, because we're storing stuff upstairs and I don't want to have a weak spot in my floor.
I mean, you
So
could put in some steel beams on either side or something and build a little box around it.
yeah, but then I'd have to tear down. My nice clean room would become a construction zone
For a while.
for a while. Yeah, but I don't know if I could get it all done before the machine showed up, if it's coming next week.
Yeah,
And
fair.
so I'd have to find a place to store it where it's not in my way. But I don't know if there's a place I can store it other than that room, without maybe, I don't know, going and renting a space or seeing if I can, I don't know, find a different place to store it temporarily while we get the room situated for a taller one. And at that point, I'd much rather spend the time trying to get the right one than trying to change my room around.
Yeah, and you don't want to move that thing more than you have to.
No. So if it's going to take me an extra week or two to get the room right and use the taller one, and we ordered it as the shorter one, I'm going to make sure that we get the shorter one.
Yeah. Is there any downside to the shorter one over the taller one?
Ergonomics. I mean, you just got to reach lower to get to the table.
Oh, is it the same machine, just literally
Yeah.
lower?
Yeah.
Oh, it's just not like it has less travel. It's
No,
just shorter.
it's the frame it sits on. It's the frame that goes underneath the granite table. It's just shorter.
Okay. I thought you were changing from like a, Model 12 to a Model 6 just to get it shorter.
No.
No, it's just the table.
Yeah, it's just how high the table is. with everything on top of it. So like
Okay.
you'll have to lean down further to load
Yeah.
parts onto it, but if I don't have to change out my roof, I mean, it would be nice if it was taller, but I would much rather I'd much rather not have to change my room out at this point.
Do you listen to the continuous improvement podcast? What's that called? Incremental. Do you listen to
Incremental.
Incremental?
I haven't listened to hardly any podcast in the last month or so, just because I've been running around traveling and whatnot.
One of the guys on there, Devin was talking about how they were building some workflows and stuff around CMMs, and I think they're in a relatively similar style. Like they do a relatively similar style of parts to what you do, where they're not fully prototyping onesie twosies, but they're not, millions of the same part. And they sounded like they had some pretty good workflows. You might want to kind of talk to him.
Yeah, I definitely will, because our parts are small enough that I could build a bunch of fixtures and just have it all staged on the machine, and either just set them in there and hit go, or make a quick change system where I could just have a whole bunch of fixtures that I could just set in there and go.
Do you know like how much calibration is required on a CMM after you move it?
No, I do not. I know almost nothing about like the maintenance and usage of it, because I'm going to be trained, and I've never used a CMM, so this is going to be a huge learning experience for us.
Because we have one at school that is stuck in the corner of a classroom that is not my classroom. And I was talking to my boss the other day about moving it to the shop floor.
So I do know that CMMs have different ones that are shop floor rated and ones that aren't. So you need to make
Theoretically, this one's shop floor rated. Theoretically. My non-technical boss says so.
Okay. I forget the technical terminology they use for that, like shop floor hardened or something. Basically, it can handle the environment it can handle higher temperature fluctuations and dirt and debris better.
Yeah, I don't worry about temperature on this one because, like, let's face it, it's in a student machine shop. We don't really care if it's, super well calibrated. But I don't want to destroy it with, dust or something.
Yeah. Because they tried to sell us a shop floor version of it, and we didn't want that because it's a lot taller and bigger than even the other one. The nice thing was, though, is that the shop floor one, the shop floor version of it, didn't require air. It only required power.
Oh, really? Okay. This one does take air, I know, or I'm pretty sure, because there's one of those filter regulators behind it.
What brand is it?
It's a Mitutoyo.
Mitutoyo.
It looks like a nice one. It's got a tool changer on it and a bunch of different probes and stuff.
That'll be cool.
I've been kind of getting the school organized a little bit more. Mostly just kind of general organization stuff. Like every single toolbox had a half completed Allen wrench set. And so I went around and collected all the Allen wrench sets and found all the loose ones and built up all the completed ones, and have been putting tools by the machines where they're actually needed. I found a set of optical flats and a monochromatic light source. So I played with that a bunch on Friday. And starting to standardize things like where tools go in the ATC and stuff like that.
Oh, one of my employees, or my employee, not the intern, he designed and ran his first part from start to finish.
Nice.
So last week.
Was that like a personal project or shop project or
shop
customer?
project? Shop project. So remember when I told you we had that extra Lang vise or Lang fixture? He made an adapter plate for the arbor press that we could put it on that Lang fixture and lock it down to the table. And it went really good, except for one problem. So he designed the model, and then I looked at it, reviewed it, we made some changes. Then he programmed it, we looked at it, reviewed it, made some changes, and then he set up all of his tools, and I looked at it, and approved it. He put it all in the machine. He programmed it, or he probed it and everything looked good, except he put in a left-handed tap, and I didn't catch it.
Yeah, that would be so hard to catch
So
until you run it.
And so like the first side where he tapped the smaller holes, they were like an M8 or M10 for the Lang pull studs. That one went fine. The other side had an M16 by 2, and we had a right and a left-handed tap for that one, and he grabbed the left-handed one. And it was funny because I told him, I said, hey, whenever you're running taps, you always got to have the hand on the e-stop, because if that thing breaks, you hit feed hold, it's not going to stop. And he's like, well, how often does that happen? I was like, it's pretty rare, but when you're testing something out for the first time, that's when things can go wrong. And, we're kind of working through all this stuff. And we did that on the first side, and it came up to the second side. And I said, remember what we do with taps? He's like, yes. We slowed it down, watched it, put his hand on the e-stop. And that's not a small tap. And it came in, and it was like a shotgun shell. It was like, bang! And he's just like, woo! And it happened so fast that, like, I thought when I looked at it, that what was the cause of it was we usually put the chamfer in after the tap. And I looked at his program, and I was like, we didn't move that start to the top of the part.
Yep.
And so I was like, that was, I should have caught that. But then we got to looking at the tap, and I was like, something's wrong with that tap. And then I went back to the box, and I was looking at it, and the box that he took it out of had an LH written on it. And I was like, that was a left-handed tap. So there might have been a problem, but because it was aluminum and it was so big, that probably wouldn't have broke it. Like if it did that. But the left hand, because the helix is the wrong angle, it just, as soon as it hit the metal, just fractured.
That's funny.
So
I hope that wasn't in the Doosan.
No, it was in the Haas. So.
Okay, good, because that would have been a new spindle.
Yeah. No, it was in the Haas. It was fine. I'm assuming the Doosan's the same way as the Haas, where you'd have to e-stop it instead of feed hold, but I don't know. That's a good question. It's a good FANUC question. But regardless, that happened, and so he was all worried about it, and it's like, it happens. It's part of the learning experience. I said, I learned something for it because, I let you take the reins, and I didn't think to check for left-handed taps. Like, especially of that size. I didn't even know we had a left-handed tap of that size.
Yeah.
I was thinking about it, and Weston had a lathe job where he needed a left-handed tap. So, because I've never used it on the mill.
I don't think I've ever purchased a left-hand tap.
So, I think he did a turnbuckle. We had a job come up with a turnbuckle where you had M16 right and left-handed threads on a turnbuckle. So, but anyways, that was pretty funny and kind of a learning experience for both of us. So which actually came up with a really good idea. We keep all of our left and right hand taps in the same box. And so me and him talked about how we can prevent it in the future. And we're going to break those boxes into 2, and we're going to print instead of, we have all of our boxes are black using the Gridfinity. And I think we're going to print red boxes for left-handed taps and move them over to a separate box to make sure that doesn't happen. Which is what should have happened from the beginning, but it hadn't been an issue and we hadn't thought about it.
Yep.
So I think that's the fix that we're ultimately going to do to make everyone a little bit more aware, because we don't have very many left-handed, but we have a couple. So, yeah, that happened. And then we're pretty slow overall, but I have this wave of jobs that if they all hit, we're just going to be swamped. So I'm like excited but scared. So
I have an experiment to report back on.
Oh, let's hear it.
So that experiment was, I traditionally was teaching this class manual machining first and then CNC machining. Like, everybody in the world suggests. And like, I've always argued for not teaching manual machining at all and just teaching CNC machining. But it is a required part of this class, whether I like it or not. But this time around, I have been teaching CNC machining first. And starting probably this coming week, I'm going to switch to manual. It has worked so much better.
We talked
I'm
about this
really,
last
really
week.
glad that I've taught CNC machining first over manual machining. And mostly because there's less things for them to learn at the same time. Since they're not the ones that are programming it, they're learning about fixturing and work holding and, kind of getting some of the basic introduction, like what tools do what, and focusing on things like inspection. Whereas, when manual machining, you're also thinking about like strategies for approaching the part and speeds and feeds and, actually just cranking the wheels and stuff like that. But by teaching the CNC stuff first, it's kind of isolating more of the variables. So we're only teaching a couple things at a time instead of trying to teach everything at once.
You know what that just gave me? Deja vu. We talked about this last week, almost word for word.
Did we? Well, last week it was less of it was still middle of experiment.
Okay.
I don't remember what happens in the podcast.
I was going to say, this is deja vu. Almost word for word. We need to clip those two.
Jacob, you have, actually, this is probably go to Josh. Josh, you have a clip to make now.
No, that's good. I'm glad to hear that it's working out that way. I actually had a little bit of the inverse when I was teaching, where I used I never taught manual machining whenever I taught, but I started incorporating it into my lessons as a prompt where we'd go and stand, and then I could like show like feed rates and whatnot and have them kind of like take some cuts on some test material to kind of understand climb versus conventional, kind of the forces that you can feel, how your RPM and your feed rates kind of play together, and like kind of get a manual feel for it and then start programming. Like we didn't actually make parts. We just took test cuts to kind of get a feel for what's a good cut versus a bad cut.
Yeah. I will say there's a couple places where I do some mixing where like when I teach how to tram in a vise, I teach that first on the manual machines and then go over and do it on the CNCs because there's just more access to everything.
Yeah.
And you're not having to think about, because that's like one of the first things I teach in the CNC class. Like we make a part and then I teach you how to tram your vise. And so they're not super comfortable with the controllers yet. And I don't want them thinking about like, what button do I press to jog the machine? The first time they do the tramming. And so I teach it on the manual machine. Then we go straight over to the CNCs and then do it there. The other thing I do is I teach them how to dial in a 4-jaw chuck on the manual lathe before we calibrate the Renishaw probes. Since the little probe mechanism is basically exactly the same as a 4-jaw chuck. Again, it's just much easier to learn on the big, 12-inch disc instead of the little itty-bitty M2 set screws. So there's a time and a place to mix it. And actually, like you said, another thing that I like to do is I'll go grab every material I can find. Like I'll grab a piece of stainless, I'll grab a piece of mild steel, I'll grab some brass, I'll grab some aluminum, and we'll just do like basically the same cut on normally I do it on the manual lathe and be like, look, brass makes little dusty chippy things. And, this titanium makes this big, long bird's nest. But, and aluminum is kind of somewhere between, well, maybe not in between brass and titanium, but
yeah,
you know what I mean? You can kind of go through all of that and
get a feel
for it. I tried doing like these are good speeds and feeds and these are wrong speeds and feeds, but for some reason, like I couldn't get it to chatter, which is never a problem I've had in my machining career before. I was like, okay, these are the right speeds and feeds for this material, and like the cut was fine. And then I was like, all right, let's crank it all the way up, and then it cut just as well. And I was like, well, that's not what I was hoping for here, but
well, to induce chatter, if you lighten your cut up over in either the axial or the radial, eventually you'll start chattering.
Yeah, I think I needed a longer stick out. Like if I had 6 inches of material sticking out, it would have chattered more. But I don't know. My setup was too good, I guess.
Sometimes taking a big heavy cut doesn't really induce chatter as much as a light cut, like a too light of a cut. So,
all right, I've got a question for you before we get to our Patreons and Q&A questions.
Hit me.
So I'm building my list of AJ's machining axioms.
Mm-hmm.
And these are the ones that I use right now in class. This is how I teach like kind of precision machining, and really this kind of revolves more around metrology when I use a lot of this. But my rules are: everything is rubber, everything is a thermometer, nothing is nominal, all corners are rounded, all cuts create burrs at unsupported edges. Always aim to undershoot adjustments, and small numbers are small until they aren't. Those are my rules. Do you have any like machining axioms that Harrison lives by?
Not that I've wrote down and summarized quite like that. Let me think.
And I should disclaimer, yes, I basically stole all of those from somebody else, Robin Renzetti or otherwise.
So hit me with that list one more time.
Everything is rubber. I don't think we need to explain that one. Everything is a thermometer. I also don't need to explain that one. Nothing is nominal. This is mostly in the context of like end mills and fixtures is kind of where I use this one a lot. Yeah. Where all fixtures are going to have some error. All end mills tend to be offsize. Tool holders have run out, etc.
Yep.
All corners are rounded. Mostly refers to inside corners when you are measuring with something like a depth mic or the butt end of calipers. Because my students like to put it right up against the wall, and then it kind of catches that fillet.
Yep.
All cuts create a burr at unsupported edges. That's mostly in context of metrology again, and making sure that they don't, like, if you're measuring a part, like a cube. If you're measuring a cube, don't measure it right at the edge, because even if you have a chamfer that you put on that edge, that chamfer then just creates 2 more microburrs. Always aim to undershoot adjustments. That is, there's 2 applications for that. So first, and this is kind of where I use it more, is let's say you're tramming in a vise. It's always better to like hit the vise less hard so it doesn't move as much and sneak up on it being perfectly square. Because if you, like, let's say you do the thing where you do half the distance every time. If you go half the distance, then half the distance, then half the distance, eventually you will get to the point where you're within your spec, within your tolerance. But if you overshoot and then overshoot and then overshoot and then overshoot your adjustment, you never actually get to your tolerance range. And that is very much a thing that I have noticed with students, is they will just go like over adjust, and they'll never actually get there.
Yep. You got to be like Happy. I was gonna say, you got to be like Happy Gilmore. Just tap it in. Just tap it.
Yeah. You could also, same phrase, different meaning, is like, if you're making a hole and your tolerance band is plus or minus 5, then you should probably aim for the -5 at the beginning and dial it bigger, because you can't add the material back.
Yep.
And then small numbers are small until they aren't. That is in terms of speeds and feeds mostly, because people will, like, you'll have a 1/16 inch end mill with like a 3/10 feed per tooth, and they'll be like, let's make it 6/10. That's not very much. It's only 3/10 more. But it's like, no, you just doubled the speeds and feeds. Or run out. Run out's another good example of this, where, it's a thou of run out. That's nothing. A thou is such a tiny number. But it's like, well, on that 1/16 end mill again, where you're taking 3/10 feed per tooth, like, that thou is actually 3 times your feed forward. So it's that's a really big number all of a sudden. But those are my little machining tidbits that I beat students over the head with.
Yeah, no, those are all really good. And they're kind of like a good wisdom things, rather than kind of what I was thinking of. I was thinking of things like always check your work coordinate system, or stuff like that.
I need yeah, that's a thing. We did have our first crash, like real crash, in this last class.
Oh, really?
Yeah, and it was a work coordinate system thing. They just didn't set their Z.
Yep. Almost all of my major crashes have been from work coordinate system, except for one which was from tool breakage.
Yeah.
So, but the bulk of them have been from a work coordinate system problem.
We've had some near misses from people who have loaded tools and then not set the length.
Yep. I would say there needs to be something about, simulation to catch crashes before you run programs. Um, you know, always simulate before you run.
Yeah.
Check work coordinate in your program and your machine, because you can probe the right location in your machine and have the wrong one in your program, or vice versa. Both of those need to match, because that almost got me with my new worker. Whenever he was running his part, he had his origin on the op2 side off of the stock that was gone, rather than on the part. And thankfully it cut higher up rather than lower down, so it just air cut instead of cutting the part. But that was one that I didn't catch. Like, we made sure we did it right in the machine, but he had it wrong in his program, even though we checked the simulation on it, and that was good. But the origin in the program was wrong.
Yeah. Like, CAM needs to match reality.
Yeah.
Is kind of what you get there. My students don't really do any programming, though I did pitch the school on doing a CAM class, like a Fusion 360 class.
Are you still setting up, like, are you giving them the origin? And
yes.
how is that communicated? Are you just telling them bottom center, back center, left corner bottom, left corner top? Like, how are you telling them where to probe?
So this is an awfully imperfect system, but I print off the Fusion setup sheet and then I draw an arrow on the little preview that it generates and write WCS on it. Because Fusion, for whatever reason, does not show your work coordinate system on that preview.
Yeah, that'd be nice. Come on, Fusion, fix that.
Yeah, it's like there's like two things you need to know when you're setting up the machine for a new part. And it's like work coordinate system and then the tools you need. And like it does the tools, but like you're missing the most important one, Fusion.
Yeah. And it needs to, like, it could be like a cube that shows you like all the different points.
Yeah.
And then it could say either like S for stock or P for part. I don't know if that would make the most sense. Model. Or F for model. Or wait, F for model. M for model. M for model.
Yeah.
I thought you said F. I was like, F for model. That doesn't make sense.
Spelling has never been my strong suit.
M for model. Okay. So yeah, like something like that. Or yeah, you could do M for model, S for stock, and P for point.
Yeah.
Like selected point. And at that point you could show the model and like where it is on it.
Well, speaking of letters, today's letters I messed up the Sesame Street reference, but P for Patreon is where I was going with that. Our Patreons help make this podcast happen. They pay for editing and hosting and all of that stuff. Patreons at any tier get or any paid tier get early access to our podcasts. Free Patreons do not get early access to our podcast, but they do also get to participate in the weekly Q&A. And then also we have a pretty cool Discord server that all paid Patreons get access to. And it's apparently where I hire everybody from. It's every single one of Subtract's employees have come from the Patreon Discord. But that's not a promise. I'm not hiring again. Don't expect that. Our new Patreons are Daniel R, Byron M, and Josh C. I think Josh C got greeted twice because he's the guy I hired. Our $10 a month and more Patreons are Daniel R, James at Moultrie Made. James, you should send me a message and tell me how to pronounce that. Ryan at Strata Manufacturing, Austin W, Kyle K, Devin at Sinister Machine Works, James N, Ben at Prickly Pear Prototypes, Cam S, Shep at Alderson Prototyping, Jacob at Zana Precision, Jason S, Joshua H, Christian Z, Freaky Climber, Prescott at 1Z, 2Z Systems, Trey V, Guy L, Alexander B, Scott at Design the Everything, Jamie at JSpec Engineering, who we should talk about later, Chris at Zyke Precision, EJ Nocturnal Welding, Chris at Thought Bomb Design, and as ever, Jake Brownson.
That list is getting longer and longer.
The list is getting longer, and my ability to say names is getting worse. Q&A, starting with Jacob. To AJ, Harrison, and the audience. When changing an order, do you require the customer to submit a formal change order? Updated PO, or just handshake/email chain good enough?
Do you want to take it, or do you want me to start?
Well, I'm going to start by saying it depends a lot on the change and when they ask for it. So if you haven't started the parts and they're like, hey, this drawing says it's 0.125, it's actually supposed to be 0.127, like, yeah, sure, okay, fine, that's not a big deal. But if you made all the parts and then they asked for that change, then you're a little bit too late. And I would want like a new PO or something in that case. If it's something minor and it's before I've started work, email chain is fine for me. If it's something minor and I'm halfway done, then I would discuss with the customer. If it's something major that requires a requote, then I would discuss with the customer.
Yeah.
And yes, I would want a separate PO for that.
Yeah. It like you said, it kind of depends on what it is. And it also kind of depends on the customer. So with some of my customers, if they just verbally told it to me, I would just take it and run. And I would make sure that is documented at some point, but I would have no problem starting on it while they're processing and getting me either an updated print or just confirming my email. Like if we talk on the phone, I want to have an email confirmation that was said and done. However, I will say with the customer, such as Walther, that actually happened where we had an email chain of a change that I had. It was a change that I had implemented, or I had modified their part a little bit just because I couldn't make it to the way that they had it done. And there was a problem on their end after the fact. And I had gotten verbal approval and I had submitted emails with changes on the drawing to what I had changed to get updated. Those changes were never updated. And so when it came time to final inspection, we had a whole bunch of parts that started failing inspection and it caused some problems. And it came back to, if that ever happens again, I am not making those changes until they are in the drawing. Even though I had verbal and I had email, they never replied back to the email, and then those changes never got pushed into the model. So
interesting.
That was an instance where they were, and the way that they were designed, I couldn't manufacture them, but I got approval to make a change, but that change never made it back into the model.
Interesting.
So
it depends.
Yeah,
just the answer to many of our problems or many of our questions.
It does, but they are a customer that, because of the industry they are in, documentation is extremely, extremely, extremely important. So
yeah. Otherwise you end up like SIG.
Yeah, exactly. And so for that reason, anything that I have from them, while I might do a handshake or a verbal on like 10 parts, like on a prototyping, but anything production, I am making it to their model 100%, zero deviations, even if we've talked about it, unless they've changed their print. So that's just an example of something that I've dealt with that, like, it was a little bit of a scare on our end because it was a lot of parts. And it was that before that, because backstory on that particular instance was they had a different customer that was making parts for them that was not providing parts. So they were collecting our parts and they weren't inspecting them. They were just putting them on the shelf as excess inventory. And so at that point, we had like 1,000 or 2,000 parts that we had made.
Oh.
And then they started bringing them into production, and we already had another 1,000 or 2,000 parts machined and ready to ship to them before they started inspecting them and actually installing them. And that's when it all failed. And at that point, we had almost 4,000 parts that were out of compliance. So
Glad you got that sorted.
yeah, it was very stressful for a little while. So yeah,
And
ended up being okay. Ended up working out, but it was a big it was a potentially very big deal.
a
So
large kerfuffle.
yeah, and thankfully it ended up not being too scary, but it was it was. I lost I lost some sleep on that one for a little bit.
Yeah.
So
And this is why I'm a big fan of in-process inspections, and because like not you guys did fine, but they should have been checking those as they were getting them.
yeah,
And smaller batch sizes also can help this, because then if something goes wrong, you catch it in a smaller batch.
well they were trying to the way they have it done. They should be flowing things through, but another customer wasn't meeting demand, and so it slowed production down. You're not going to slow all your other vendors
Oh, I
down.
understand.
So it was like they were unable to produce them. So our stuff was just going on the shelf until they were able to.
Okay, that makes sense.
So
Next question. This is from Greg. As a self-taught machinist, I tend to avoid thick parts. I've seen people working with parts that are 4 to 5 inches thick. Do you have any tips or tooling suggestions for approaching parts like this?
what's our best answer for this? It depends.
It depends.
So
I would advise tools that are at least 4 or 5 inches long.
well, I've had to do that on a couple parts. Not 5 inches. That's a little too big, but
Girthy.
um, girthy. But if you can rotate the part and still maintain setups, like for example, if you have like a big plate or a block, and you can face two of the ends to thickness, and then add your features on top and bottom. The parts that have been that thick, I've been able to do that method where I get it to thickness, and then I'm able to machine everything on top and bottom and basically do it in 4 ops. That way I can avoid longer tooling.
Yeah, like old school squaring up your block before you get started kind of
Yeah,
work.
kind of that process. That's one method I've done. And then the other method I've done is like just really long reach tooling with like short flutes. So
Yes.
like reach down as far as I can with my standard tooling, and then go to shorter, like the solid carbide with the short flutes at the bottom, the long reach ones. So
I like those a lot. Now, granted, I'm doing like I'll have like an 1/8 inch tool with like 16 times diameter reach, and that's the way I do it. Is I like the ones that have stubby flutes on the end, but a long reduced neck section.
yeah. And so there's a little bit of it depends, like it's really part dependent on what strategies you can use on that stuff. But I tend to try to avoid long tooling unless I have to do it that way, because
Let's ass-
there's always more deflection with longer tooling.
let's assume you have to. What kind of tool holder would you go for? Like a hydraulic, I would think in this case, or for the dampening.
Yeah, that would definitely help. I mean, I've done everything so far in an ER. I only have one hydraulic holder currently, and it's in the Doosan. And so I've done it with ERs. I know the better holding you have, it'll definitely help. And the thicker, the the more you can reduce your stick out to diameter ratio, the better as well. So, 4 inches is a long ways to go down, but if you have a 1 inch diameter tool,
That's pretty doable.
that's pretty doable, because that's only a 4 times diameter tool.
Assuming you have the machine rigidity.
Yeah, yeah. So, and if you don't have, well, if you're trying to do a 4 inch depth and you had a 30 taper machine, I would try very hard to to not use long reach tooling, but if you had to, the less flute engagement you can get and the thicker the diameter tool you can get, that's kind of the best combination there.
James N., do you guys have opinions on how to buy a used machine, what to look for and inspect? Harrison, have you or your employees had any issues jumping from Haas to FANUC?
Well, for starters, I haven't purchased any used machinery. Have you? Well, I know you have. You've got the Haas.
Yeah, I've got the OM, which I definitely bought sight unseen, but
yeah,
that's probably not the way to do it.
Yeah. If I was buying a used machine, some of the things that I would definitely check is I would want to make sure it was connected to power so that I could power it on and make sure that everything is functioning. I would want to do every function on the machine. Tool change, run the spindle up and down, run coolant, through spindle coolant, move all the axes. If there is a feature on that machine and it is plugged into power, I want to see it work. Listening for things, making sure the spindle sounds good all the way up to max RPM, making sure your tool changes are good. If you're worried about tool changes, I would tool change to every single pocket. Make sure there's not one or two pockets that have problems. If you've got a probe or a tool setter, I would want to check both of those. If you've got a 5-axis or 4-axis, I would want to do some sort of test to see if there's any backlash or what type of tolerances it's holding, like MRZP. Or if you're doing a 4th-axis, do something to like put a bar in it and kind of wiggle it and see if you can feel any backlash in the mechanism. I've never bought a used machine, but I feel like this is the stuff that I would want to check. If I'm putting it in, I would want to see. I would want to make sure that its power requirements meet my building. If I'm buying used, I want to make sure it's not and I only have like 220 or 240 volt, but it's 480. That's a problem. Or if that machine has the option to come in single phase or 3-phase, I would want to make sure that it's the right power requirements. I mean, I'm just throwing out stuff to check. I don't know if there's anything you can think of that you'd add.
I would check the spindle taper very carefully. That's a kind of a good indication of how well the machine has been treated. If the spindle taper is really clean, then that's a good sign the machine is well taken care of. If it's, corroded and got dirt and gunk and chips up there, that's a pretty good sign that it's been abused.
If you're buying it from the person who's been running it, like not from a reseller, but from like an actual shop, I would want to talk to the shop and figure out why they're getting rid of it. Because you can tell a lot if you can find the people who've used it last. Oh, if the machine's been sitting in the corner because they just haven't had a need for it, or they're upgrading it because they upgrade all their machines after so many years. Like, you can learn a lot. I would want to know what materials it was running and what type of work it was doing. Because wasn't yours doing like a lot of ceramics?
All used machines only run aluminum all day.
Yeah.
Or plastics.
Yeah. But like if it was running cast iron all day or ceramics, fiberglass, like those are all things I would want to know. Because that can really mess with some different systems depending on what they're doing with it.
G10 and graphite are other ones to look for.
Mm-hmm.
The graphite machines are pretty obvious.
Yeah. If a machine has a lot of high hours, but either A, looks like it's been beat to death, or C, looks like it's clean and never run, but it's got high hours, both of those could be red flags. So if it looks really clean and it's got really high hours, I would want to know what material they were using. Because if they were cutting something dry, they could be like a dust to get into stuff, but that's easy to like air out, but you can't necessarily check behind the covers. Like, I don't know if like that. I think of graphite like that. I don't know for sure if graphite's that easy to clean.
Graphite leaves machines black.
It leaves them black.
It is not very obvious.
You can't just wash them off that easily.
You're washing off pencil lead. Like,
gotcha.
I'm not saying it's not possible, but every graphite machine I've seen has been like it looked like it came out of a coal mine.
Okay, so like I would just look for indicators of that kind of stuff. So Um,
Yeah, like if they were running a lot of like G10 or like glass filled plastics, I could see that being harder to spot.
yeah, which may or may not be okay, but I would want to know.
EJ said, "Oh wait, no, you have one more. Jumping between Haas and FANUC.
So I've gotten relatively used to it. The FANUC controller does FANUC things, and it's
FANUC be
just
FANUC.
FANUC be FANUC. And so, like, it was funny because my employee is learning how, like, I've got him learning how to use the Haas machine. And then for kicks and giggles, I was doing a tool change where I was taking a tool out of the machine and putting a new one in. And I showed him the button presses and the sequence to properly do it. And he's a computer programmer, and he looked at me and he goes, "That is some jank crap." Like, he's like, "I'm not gonna know that for a long time." And I was like, "Yeah, I know." But I wanted to at least give you an idea of the difference. He's like, why is it so hard?
I think we can safely say this podcast is never going to be sponsored by FANUC.
I mean, it's a solid machine, but for like, I can understand why people like FANUC if once you get used to it, but it's not user friendly.
Nope. EJ asks how to make parts faster to be more profitable. I bet Jacob truncated that a little bit. How do you make parts faster and be more profitable? His parts tend to take him a long time. Is it just experience? Is it big brains? Or having a good process?
I would say it depends on how many of the parts are you trying to make will depend on how efficient you need to be. So
With
if you
EJ, let's assume like onesie twosie prototyping kind of work.
then yeah, with EJ, I would say for you, it's going to be a combination of feeds and speeds and good processes for understanding how to attack a part.
Yeah. I don't think it's like I just need to have the machine run less time. I think he's more getting to that first setup, like getting the part running.
Gotcha. So it's not actual runtime, it's like looking at the whole process from start to finish.
Yeah.
Is EJ using Toolpath? Do you know?
I think so, yes.
So programming is he doing that, or is Toolpath doing that all for him?
I don't know.
Okay. So I mean, assuming you have Toolpath doing the programming for you, then I would there's definitely like programming things you can do to speed things up. I don't have a list, but I have like a mental list of things that I check that can make a huge difference in speeding things up. Just little things here and there can make all the difference in the world. But as like a general thing, I mean, it's kind of just something you learn with time. There's
Yeah.
not like a magic bullet for any of this.
I would say like in the kind of prototyping job shop space where you're doing small quantities, getting the part done right the first time and not having to make it again is like the first big hurdle.
Yeah.
So focus on things that you need to do to make sure that you don't need a setup part. Make sure that you're getting it right the first time. So that may end up with a super overly conservative program where you are taking longer and like, on holes, if it's, anything tighter than ±5, leave some stock to leave on there the first time and walk it in. And, do that on anything that has anywhere remotely to a critical tolerance. When you flip it for op 2, when you take your first pass at it on that second side, leave yourself some extra meat and then walk it in. It's slower. It might take you 3 times longer to run the part, but it's always faster to make it right the first time. And then you'll get everything else, you'll speed up with time. Standardized work coordinate system, standardized tooling, standardized speeds and feeds, get a 0 point if you can.
I would say when it comes to making sure your tooling's on size, I know if you're using an umbrella style tool changer on the Haas, you can only have so many tools. And so if you're constantly having to change out tools, because you can only have, say, 10 tools and umbrella, and so you're constantly renumbering tools. I would definitely want to tag my tool holders and have things like the length of the tool, the diameter or any wear offsets, and like have all that information with that tool, because when you have everything properly dialed and properly set up, you can hit your tolerances almost bang on every time if you have a properly set up tool and in the controller. And if you have a good process for roughing and finishing, like if you do the same thing every single time, you're going to hit those tolerances almost every time. Like I've got some tools that I only use on some parts, and all the wears and everything are saved in the controller, and those parts are tight tolerance, and I can just load it up and run it and hit plus or minus 2 thou every single time. And I don't, and it could be months apart, but I only use that tool on that part, and it just holds it. It just works. So like you can hit tight tolerance stuff, but you have to have your tools set up right in the controller, and you have to do the same process for roughing and finishing on all your parts, and then you can hit your dimensions, and it's just a lot easier to get it on that first try. But I would say there's 100 small things you can do to make things go faster. But start by getting good parts without fail, and then worry about speeding it up from there. Like
Next
what you
question,
said.
Freaky Climber. AJ, after your used car purchase situation, should I buy a marketplace freezer? Did that just lose you entirely? Are you familiar with the Prius?
I am at a loss. You're gonna have to explain this to me.
So I bought a new car, and by a new car I mean a very, very used car.
Okay.
And I've gone back and forth between like immediate regret and kind of accepting it to kind of a little bit more regret. And it definitely has some problems. It's a 2008, I believe, Prius. I got it because I've been driving back and forth to school so much, and it's relatively long, and so the gas mileage would pay off the car pretty quick. Originally, I had a budget of $5,000, which there's some pretty good used Priuses for under $5,000. I really only need this car for like 11 months or so is when I'm going to be doing this driving, and after that, I probably just sell it back off again. Well, I found a car that seemed to check all of my boxes, and it was only $1,500.
Oh.
And I was like, well, what's the worst that can happen? And I went for it. And then just like, I was very annoyed by it. One, there was a couple things I missed when I test drove it. One, the air conditioning doesn't work. I thought it did, but it does not. The day we bought it, it was so hot. It was like record heat, and the sun was like super, super, super intense where we were. We're just like in a parking lot, and I drove it around, and I thought it was just hot because it was crazy hot out at the time, but the air conditioning wasn't working. And then also like the speedometer fuel gauge instrument panel doesn't work. And I thought it was just like so bright out that I couldn't see it. And like I knew it had some things, like its exhaust is loud, like that one I knew about. And
does the battery pack work?
So the battery, the hybrid battery in it is actually fine, and that hasn't been any issues. When I first drove it home, it did throw a weird alarm. But that's never come back again. It's only shown up once, and now it's disappeared. But driving it again, after a couple days of driving it to school and back, it started having some weird electrical gremlins. And upon further investigation, not only does it have the wrong kind of like normal 12-volt battery, like car battery in it, because they used the wrong kind of battery, they had to like hook it up in via jank methods.
Mm-hmm.
And so like the ground wire is held on with a hose clamp. And I think that is causing some of the electrical gremlins. and I haven't gotten around to fixing them yet.
Have you looked at your AC?
So I had someone out, a local mechanic, and he had like the leak checker and things, and he found the leak, and it's supposed to be. He says it'll be really cheap and easy to fix. He, what happened? Oh, like we had scheduled a day, and then we had to cancel it, and like for him to come back and fix this, and then we just never got around to rescheduling. So I need to bug him. I also had this little hiccup with some cash flow where like the school screwed up its payment to me, and like I was waiting on some like money from Xometry, and I went like 2 months without a paycheck from anywhere. And so I wasn't upset that he didn't answer because I didn't really want to pay him, because after 2 months of not having any income, my emergency fund was rather low. But that's all fixed now. So I should probably have him back out like this weekend or something to come fix the car. It also needs some coil packs.
So what you're saying is you're going to end up buying a $5,000 car, whether or not you spend the money on the actual car or not.
Yeah. Oh, the other thing I did is I knew it needed tires. I knew that when I bought it. And I bought 2 new tires, but this was on me again. Is I brought it into like a discount tire, and it's like, hey, I know these tires are rough. I think I'm going to need all 4. And they came back. They're like, oh, it only needs 2. And I knew there were 2 tires that leaked. And so I was like, okay, fine. If you think the other 2 are fine, like I just want to drive this car for a year. I'm okay with just, having 2 tires that are a little bit worn and 2 that are new. Well, the 2 tires they replaced were only one of them was one that leaked. So I still have 1 leaky tire. So I probably just need to go get the other 2 tires now. But total on this car, I'm in with registration, which cost more than I thought it would. It cost me like $300 to register this thing. But with registration, I'm only $1,800 in right now. Oh no, with tires, so I'm $2,000 in.
And then after the mechanic and the AC, probably
well,
another
he hasn't
couple
done
hundred
that
bucks.
yet. I'm not in there yet.
Another couple $100.
So even if I'm at 2,500 and it lasts for a year, I'll be fine. Because right now I'm spending like $50 a week on gas. And so if it cuts that in half, which if it works, it will.
Yeah.
But when we last did this, when I talked about buying this on the podcast with Jacob, Jacob's like, I built my own swap cooler with a cooler full of ice and a fan, and Freaky Climbers hinting that I should probably do the same. But I did get to drive the car for like 2 weeks before it started having its weird electrical problems.
I gotta find something from way back when, because I actually have a funny story. I did something very similar to what you're talking about with my old job. I bought an old, it's around a 2008. It was a Volkswagen Golf. It was a diesel and it was a manual. And I had been comparing it to driving my Fox Body Mustang, which got 15 miles to the gallon. And I was driving almost 100 miles a day. So I had to fill up the Mustang every other day. And then I switched to that car, and I tracked the mileage and the fuel prices, and I had it all in an Excel sheet, and I tracked it for about a year and a half. And basically I could have drove that car off of a cliff and come out money ahead by the time it was all said and done. And I ended up having to get rid of the car because I started dating my now wife, and the person who had it before me thought it was a race car, and they slammed it. And my wife lived down a gravel road. And I went to drop her off one night at like 8 or 9 in the evening. And it was dark out, and we're going down the driveway, and she yelled at something that she thought was on the road. So I swerved, and I swerved right into a massive rock, and it put a massive hole in the oil pan. Uh-oh. And her driveway was about like a mile long dirt driveway. And this was at the very entrance. And when I got to her house, my check oil light came on. And I was like, oh, did that rock hit the oil pan?
Yeah. Oh no.
And we got out with a flashlight and we hopped in her mom's car and we drove up the driveway and you could see a whole line of oil all the way back up to where that rock was. And so I ended up having to stay with them for the night with her and her parents. And then in the morning, my dad had to come get me with a trailer. And I had to call into work because it was dropping her off on a Sunday evening. It was Monday was the next day, and I had to call in and be like, I'm not coming to work tomorrow. And so after we got the car fixed, I ended up selling it and getting the Fusion I have now. So, because I was like, if I can't go down this driveway with this car, if I'm going to keep dating this girl.
Yeah, that's funny.
So, but I was going to see if I could find the old Excel sheet I had for that, because it was a pretty cool Excel sheet. It had a lot of information. So
I figure worst case scenario, we get the AC fixed, we replace the coil packs, and I'll put a new battery in it. I'm at like $2,000 or something at that point, and I think I could sell the car for $2,000. So I don't know. It is what it is. I could probably sell it right now for $1,500 again, and then I'm basically just out whatever I paid for taxes and registration.
Let's see. Yeah. Well, I mean, it sounds like it could be a good deal if the car doesn't have a ton of problems. I mean, it's the same thing that happens with all vehicles, and this kind of ties into our whole machine talk. You can get a really good deal. You gotta do your due diligence when you're purchasing it, because I've definitely looked at some used machines. I didn't want to get some used machines in the beginning because I didn't want to rely and worry about the gremlins. But like, if I've got a few solid machines, and I have excess capacity, if a used machine stops working, I'm more willing to buy used at that point, depending on the reason for buying it. Like, if I'm buying a machine because I have a customer who wants me to do 60,000 parts a year or something like that, I'm probably going to end up buying new because I can build that into the price of the job. But if I'm just starting to run a little lower, running out of capacity in a couple areas, and I want to try a new machine, I'm more willing to try used at that point.
There's also a difference between a 25-year-old Fadal and like a 2023 VF2.
Yeah. Yep.
Not that Fadals ever die, but
yeah.
Well, anything else?
Nope, not that I can think of. That was all the questions for now.
That was all the questions.
So you didn't answer. Should he buy a freezer off of Facebook Marketplace?
You do what you want, buddy. What you could do is fly to Indianapolis and then help me fix my car. I meant to work on it yesterday. I have a battery for the truck that I thought the truck needed, and then it turned out that it didn't, and so now I just have an extra battery. And it's the wrong size and terminal hookup for the Prius, but I think I can make it work in a less sketchy manner than what they did. And if that fixes the electrical gremlins, then I'll just get the right battery for it. And if it doesn't make a change, then it's not actually the battery. I was hoping I was wanting to test that yesterday. My allergies were so bad yesterday that I might as well have been sick. Like, from what I understand, there's some more forest fires going on that we're getting the wind from. And my eyes were burning so bad that I couldn't keep them open.
Oh, wow.
It was, I have bad allergies. They're better now than they were as a kid, but I've got, raccoon eyes, and I'm pretty sure that's from allergies. Everyone thinks I'm iron deficient, but they get red and puffy when I get allergies. My allergies are bad. And yesterday was really bad, so I didn't work on my car.
Fair enough. All right, guys, it's time to say goodbye, and thanks for hanging out. So thanks for hanging out with us and listening to our ramblings that got kind of way off topic there towards the end, but it wouldn't
be
my
fault. It's freaking Chris' fault.
It wouldn't be a Tax and Patience podcast if things went smoothly. So, thanks for hanging out with us and listening to our journey. Please, like, if you got any questions or want to learn anything or ask us, feel free. And we should probably like get a guest on here soon or something. So,
I forgot to say, what's it? FabTech meetup, FabTech this year. I still need to talk to the Articard guys to figure out a day. I think they sent me a message that I haven't answered yet. But IMTS meetup at the Articard booth. No, FabTech meetup at the Articard booth at a day that I haven't specified yet, at a time that I haven't specified yet. If you are interested in coming to that, shoot me a message. And I really need to talk to the Articard guys because I haven't yet.
So add it to your calendar. Time unknown, date unknown.
We have a place though.
Place known. So, anyways, thanks for hanging out with us, and don't got anything else. So this has been Harrison with Precision Ingenuity signing out with AJ from Audacity Micro and Subtract Manufacturing. Catch you guys next time.
Bye.